Hello friends, let us now learn about the first chapter in radiology about radiation. First, the X-rays were discovered by a German physicist William Conrad Röntgen in November 8, 1895. So he built a cathode ray tube, and in his cathode ray tube there is a cathode and there is an anode. Cathode and anode are made up of platinum, and these were placed in a glass envelope, and this is the glass envelope, and this glass envelope does not contain air, that is, air is removed from this glass envelope. Now when the cathode and anode are connected to a high voltage battery, then the electrons from the cathode ray tube will uh, bombard the anode. So the electrons from the cathode will go and they bombard the anode. When the electrons from cathode bombard the anode, so at that position the X-rays are released. So these X-rays are exposed to a chemical called as barium platinocyanide. So when the X-rays are exposed to this barium platinocyanide, this will undergo fluorescence, and based on that we can detect the X-rays. So by this he had first discovered X-rays. So once he had discovered this unknown rays, and these unknown rays are named as X-rays by him, and now that he started experimenting, so he started placing different objects in between this cathode ray tube and the fluorescent screen, that is barium platinocyanide. So when he placed wood, aluminium, he had got different types of images. So based on that he conducted many experiments, and one day his wife placed her hand between the X-ray tube and the fluorescent screen. So when his wife placed his hand, that is, when he held his hand, or his wife held his hand between this, then he was surprised to see the outline of the skeleton on the barium platinocyanide or fluorescent screen. He had seen the X-ray of hand. So by this he had decided that these are very important rays, and he wrote a manuscript describing all his experiments, and for this rays, that is invisible rays, he named as X-rays, and he was awarded Nobel Prize in the year 1901 for his work on X-rays. So what are X-rays? X-rays belong to a group of radiation called as electromagnetic radiations. So these electromagnetic radiations, they transport energy in the form of both electric waves and magnetic fields. The electric field and magnetic field are perpendicular to each other. Because the X-rays travel or transport the energy in the form of electric and magnetic field, we call it as electromagnetic radiation. So this electromagnetic radiation also includes other types of waves. Like along with X-rays, electromagnetic radiation includes radio waves, visible light, gamma radiation and X-rays. So how are these X-rays or electromagnetic radiation produced? So when an electron or a charged particle is accelerated, it bombards the electron from the outer shell. When it bombards the electron from the outer shell, so this electron is removed by force, or electron is charged. So when this electron is charged, so this electron is removed and it travels and when it hits the anode, it produces X-rays. So we will see about the production of X-rays in our next class. This is just the introduction. So let us see some important concepts about electromagnetic radiation, and then we'll go about in X-rays. So first, in electromagnetic radiation consists of two main things. One, it has an electric field and it has a magnetic field. Electric field and the magnetic field are actually perpendicular to each other. If you see, they are perpendicular to each other. Electric field and magnetic field are perpendicular to each other. The electromagnetic radiation has two main concepts. One, there is wave concept and there is particulate concept. Over years, many scientists have researched about the wave and particulate concepts of electromagnetic radiation. Then they have come into the conclusion that electromagnetic radiation contains both waves and particles. It is not just particles or it is not just waves. So both these theories uh, give a meaningful explanation about electromagnetic radiation. So if we see the wave theory of electromagnetic radiation, all electromagnetic radiations, so electromagnetic radiations include radio waves, X-rays, infrared rays, so all of these will have a same velocity in the vacuum, and this velocity is equal to the velocity of light. So the velocity in vacuum, that is equal to the velocity of light, is nothing but 3 into 10 to the power of 8 meters per second. This 3 into 10 to the power of 8 meters per second is the velocity of light or velocity of electromagnetic radiation. So when the electromagnetic radiation is traveling in the form of waves, so when it's traveling in the form of waves, we can we can deduce two different parameters. One we called as wavelength. What is wavelength? Wavelength is the distance between the two crests or two troughs. This elevation is called as crest. Crest is the topmost point of this radiation, and the distance between two crests is called as wavelength, or distance between two troughs is also called as wavelength. So frequency is number of waves in a unit time. If we have calculated for 1 second, so number of waves, so here 4 waves, so 4 is the frequency. So frequency is the number of waves per unit time. It can be any time, it can be 1 second, 10 seconds, 20 seconds. So frequency is the number of waves in unit time. Wavelength is the distance between the two crests or two highest points or two lowest points. So we can calculate velocity by the equation velocity is equal to wavelength and frequency. Wavelength is given by wavelength is given by lambda and frequency is given by nu. So velocity is equal to wavelength into frequency. So if we calculate, so if velocity is 4 feet, if wavelength is 4 feet and frequency is 6, so we have got 240 as velocity. So, as we have already said, all the electromagnetic radiations, which includes the X-rays, gamma, X-rays, radio waves, visible light spectrum, ultrasound waves, ultraviolet rays, all these will have same velocity, that is equal to velocity of light, which is nothing but 3 into 10 to the power of 8 meters per second. But all of them have main difference is in their wavelength. Wavelength difference is equal to is nothing but that if there is difference in frequency or there is difference in wavelength. So the wavelength is actually a length, it is distance, right? So distance is calculated by meters or centimeters, meters in SI unit and centimeters in CGS unit. Okay, but if you see the wavelength are like they are very small, like they were not in normal meters, they will be in 10 to the power of minus 10 range. So as a result, they are given a special unit called as angstroms. So this is angstrom. Angstrom is equal to 10 to the 1 angstrom is equal to 10 to the power of minus 10 meters, or they can be calculated in nanometers. Nano means 10 to the power of 9. So 1 nanometer is equal to 10 to the power of minus 9 meters. So wavelength of X-rays is in the order of 1 into 0.1 angstroms. So we should remember this for sure. Wavelength of X-rays is in the range of 1 to 10 to the minus 1 to minus 1 angstroms. 1 angstrom is equal to 10 to the power of minus 10 meters. So we also have all these are actually electromagnetic radiations. So other electromagnetic radiations like the radio waves, television, radars, or infrared radiation, visible light, UV light, soft X-rays, diagnostic X-rays or therapeutic X-rays, all these have different wavelengths. Among all these, you should actually remember this visible light wavelength, which is equal to 7,500 to 3,900 angstroms, and it is also important for you to remember the wavelength of diagnostic X-rays, that is 1 to 0.1 angstroms. That is wave concept of electromagnetic radiation. If we just summarize, so electromagnetic radiation wave concept states that electromagnetic radiation travels in waves. So they have wavelength and they have frequency. So velocity can be calculated by the sum of wavelength and frequency, and all of them will have a velocity which is equal to the velocity of light. So if you see the next concept, that is particle concept of electromagnetic radiation. In particle concept of electromagnetic radiation, the electromagnetic radiation travels has particles. So when they travel as particles, they will react with matter. So when they travel as particles, they will react with matter. So if you see, X-rays are nothing but the pockets of energy, or they are photons, and these will travel with the speed of light, which is 3 into 10 to the power of 8 meters per second. And these pockets of energy also have a frequency of radiation, because they are pockets of energy, that is, they are particles. So if it is waves, they travel in the form of waves, but particle concept tells that the X-rays are particles. So if the X-rays are particles, they will start vibrating per unit second. So the vibration, they will start vibrating. So vibration will depend upon mainly the frequency of radiation. So what is frequency? Frequency is, in 1 second, the number of vibrations per second is called as frequency. So number of vibrations per second is called as frequency. So the pockets of energy, or phantom or quantum, depends upon the frequency of radiation. So here the energy, so X-rays are nothing but the pockets of energy. So these energy are dependent upon the frequency of radiation. So energy is directly proportional to the frequency. Frequency is given by the symbol nu. So this is nu. So frequency is given by the symbol nu. So energy is directly proportional to frequency. So energy is equal to h nu. Nu is the frequency. H is called as Planck's constant, which includes 6.6 into 10 to the power of minus 4 joules per second. So finally, if we combine both these concepts, that is, if we say the electromagnetic radiation is made up of waves and also made up of particles, then if in the wave concept we have seen that the velocity is equal to nu lambda. So if we just change it, so nu is equal to velocity by lambda. So we, in the particle concept just now, we have seen energy is equal to h nu. H is the Planck's constant, nu is the frequency. So the frequency is same here. So if we substitute this to here, we will get energy is equal to hc by lambda, right? If we substitute this in place of nu, so energy is equal to hc by lambda. So energy is equal to hc by lambda. So if we calculate h, we already know, that is 6.62 into 10 to the power of minus 34. Whereas c we also know, that is nu, c, that is c is velocity. Velocity is equal to velocity of light, that is 3 into 10 to the power of 8. So if we multiply this, we will get energy has 12.4 kilo electron volt per lambda in angstroms. Okay, so the summary of this chapter is, the X-rays are electromagnetic radiation. So these electromagnetic radiation can be waves or particles. So if it is waves, they travel with the speed of light. So nu is equal to c lambda. If it is particles, then energy is equal to h nu. But recent concept says that the X-rays or electromagnetic radiation can travel both as waves and both as particles. So as a result, we have deduced the equation, which is energy is equal to 10 to the power of minus 4 by lambda. So this states that energy depends on wavelength. So in the next chapter, we will learn about the X-rays and the production of X-rays. Thank you.